Robin is going to give the following session. It's going to be an hour and a half long, and this will be the last session for today. So yeah, thank you.
Okay. Welcome, everyone. So I'm going to present about Ardour and Lua scripting, and I'm going to really go literally like that. First, introduce what is Ardour, which many of you may know. Then I'm going to give a very basic introduction to Lua, and finally show some example scripts. And the idea was to do a workshop with 5 to 10 people in a room, sitting and everybody hacking on it. So I'm not sure how this will work in a setting like this. Maybe we can improvise, like I can show some example code, or you can copy it, or you can ask questions. First of, why am I doing it? I started working on soundtracks back in 2006 and 2007, and I was running Linux, and back then almost no software exists like that, so I started getting involved into Ardour. And over time, I became more of a programmer than a musician, and since 2017, working on Ardour is my full-time job. So I'm also trying to introduce it to to you guys, what you can do with it. And especially customization is going to be important, because it's also what I did when I needed a new feature. I was just being able to add it to Ardour. So first of all, what is Ardour? Ardour is a cross-platform, free Libre digital audio workstation. And digital audio workstation is defined by you can have unlimited multi-channel tracks. It's important that you can do non-linear, non-destructive editing. Non-destructive means once audio is recorded to disk, it will never change. So it's all the editing that happens is changing the metadata of the existing data on disk. You have massive multi-tracks. Usually in an audio workstation, you can have up to 200 or even more tracks for when you're doing mixing. You do real-time effect processing. It's also follow up that audio on disk doesn't change, as opposed to a sound file editor where you do actually change the data on disk. And you do automation for doing the mixes. These days, there's a lot of additional features that are expected from audio workstation, like MIDI editing, like clip launching, playing virtual instruments, and it's a moving target of what defines an audio workstation. So what can you do with it? Well, you record, import audio MIDI, then you edit, arrange, you mix or master your record. Finally, you export it for someone to listen to. You can remote control a DAW, which many people use as a control surface or mixing desk. And most importantly, with the free software workstation, you can customize it to your need, and you can hack it as well. Who uses a DAW? Musicians, obviously, audio engineers, podcasters, and there's a lot of them which I didn't know beforehand. When I was presenting this at the Ubuntu Summit last year, there were at least 20 people who use Ardour for doing podcasts, and they have a completely different use case as the classical audio engineer, or soundtrack editors, or composers, or multimedia artists. So it's become important that it's possible to customize or extend the DAW, because most people just use 2%, and another user uses a different 2% of the DAW, and a third user uses another 5%. So there's a whole range of features that a DAW needs to support and cater for each of the different use cases. And that's where it's important that you can customize it and extend it. And of course, Ardour is free software. You have the C++ source code, so you can go ahead and customize away. But then again, that's not really trivial to do. Recompiling is a long turnaround time. It takes, well, on some machines, even up to 10 to 15 minutes to compile Ardour from source. And when you add a new feature in C++ to Ardour, there's rigor required, and it needs to work for everyone. If you ever develop software by yourself, you find it's super easy to make something that works for yourself, and then you try to get someone else to use it, and it breaks apart, and it takes a lot more work to get something to be done that works reliably, and then you can distribute. So, scripting to the rescue. A big part is that you can, help yourself, first of all, but you also sidestep all the compiled language requirements. A Lua script is compiled dynamically. you can modify it on runtime, and it's just in time compiled. That's what the JIT stands for. So you can write dynamically code, and it's immediately executed while you're working on it. And the scripting is very important for one-off use cases, something that you want to get quickly done, and maybe you don't even want to get upstream, like something that only works for yourself, or for a specific art exhibition, or for something that is very unlikely to be even included upstream. As a side effect, scripting helped a lot to prototype new features in Ardour as well, because we can do a basic implementation in the back end without writing a new UI, and just use scripting to interoperate with it and explore new features before committing to write the actual C implementation or creating a UI for it. Another important factor is for many audio workstations like Reaper, scripting is the only way to extend the audio workstation. They're closed source, so their scripting capabilities have a completely different target user group. And in Ardour, since the C source code is available, we can focus on dedicated parts that we allow to be scripted and not try to expose the whole ecosystem at once to the user. So, meet Lua. Lua is Portuguese for La Lune, the moon, and also pronounced as such, like it's not capitalized. And we use Lua because it's a very lightweight and a fast, embeddable scripting language that has a very simple syntax and is easy to learn. It's also cross-platform, so like we can just take it and it works on all the platforms that Ardour supports. And it's importantly one of the few real-time safe scripting languages. There's the other one is AngelScript, and then there's also a more obscure one from Super Collider called Supernova. And pretty much all JavaScript or Python is not possible to use in a real-time context because there's a global lock, there's memory allocation issues. So we pretty much didn't have any options there other than Lua for integrating it if we want to do real-time processing as well. And this is going to be probably too simple for most of you guys. I was asked yesterday, like some people don't know Lua at all, and then there's one guy who already contributed to Ardour and is very fluent in Lua, probably more than I am. So I'm going to explain a very brief introduction to programming in general and how those programming concepts are implemented in Lua. So what do you do when you program? The first simple thing is you assign values to variable. Also what happens on the screen, you just say this pixel up there is white or not. You compare values, then you branch, you do something if a comparison is true or false. You do loop, and you call a function to do all of the above. I guess most of you guys are familiar with those concepts. So first, see how assigning values to variable works. In Lua, you can use any identifier. Here I use just A as a variable. And print would be a function here to just print the value of the variable. Initially, A is not initialized, so it prints nil. The second line, I assign 10 to a variable, and then I print it, and it shows 10. And Lua is dynamically typed. So the type of each of the variable, like in this case it's a number or a string, is stored with the variable itself. And in this case, I can just assign a string, or in this case, concatenate a string with 2 dots, and also just print it. And Lua has a very limited type of variable types. The first would be a string, and the function type that you can see here shows the type of the variable itself. Because it is stored in the variable, you can retrieve it. There's a number which is always double precision. And you can assign functions to variables in Lua as well. They're first-class citizens, which is very handy. There's Boolean, and then there's undefined, in this case, nil. And you can see in the later lines that you can also assign a function to a variable and then just use the variable to call the function instead. This is going to be important later on because bindings work like that as well for exposing Ardour functionality. Going through basic loops, there are 3 ways to do loops in Lua. One is a basic for loop, where you define a start and an end. And this just prints the number from 1 to 10. All of them do. The second one is a while loop, where you first check if condition is true, and then enter the loop. And the last option is you first enter the loop, and only afterwards you check whether the condition is true and to repeat. So the difference between the last two might be obscure, but there's a nice graph that showcases how those two work. Okay. A last type that you have in Lua are called tables. You've seen them earlier already in the presentation by Albert. And a table is an associative array that can also be, well, nested in itself, and it's a very powerful structure in Lua to use for both saving state, or in this case, or just iterating over values, which are going to be useful later on for processing audio samples, which are pretty much an array of values. And here are examples how you can assign values to a table. And one important thing to notice in Lua that indexing starts at 1 and not 0. So the first element is number 1. You can also loop over tables. That's where the for function comes in that we've seen earlier. And you can there's a special function called pairs that groups elements of a table, and you can just print them as key value pairs directly. In this case, it will just print in all the days of the week. But the key in this case would be 1 Sunday, 2 Monday, 3 Tuesday, because the indexing automatically works when you assign tables anonymously like this one without a dedicated index. And last but not least, functions. This is going to be a simple factorial for those of you who remember high school math. 4 factorial is just 4 times 3 times 2 times 1. And this is implemented as a recursive function in this case. It means the function calls itself. You can see the, you go first, and there you enter a number, which is a factorial of 4. We check it's not 0. So we go to the second part, we go n will be 4 in this case, and we call ourselves with 3. So it's going to 3, and then recurs itself, and it's still not 0, and so the function enters itself until we have the whole 4 times 3 times 2 times 1, and this returns 24. So far we've seen almost all of the syntax keywords that Lua supports. I should have mentioned earlier that every function is closed off with an end. There's no curly brackets in Lua at all. So you have a function, or a if, else, end, and the function itself also ends with an end at the end, which is a reserved word in Lua. We've seen in the for loop, repeat and while we've seen, return for the function, and then do for, and if then, and well, true was in one of those functions, defaults is the other one, so that's like a very limited syntax, which is kind of nice and makes Lua easy to learn, even for newbies. If you know any, well, other programming languages, you can translate your knowledge to Lua easily. So what we've seen right now was a free function that you can just call from Lua, while in Ardour, really everything is object-oriented. And the functions are not free functions that you can just call, but they're linked to a dedicated object. The most common one would be the Ardour session. And the session provides functionality like go to start, role transport, and you can also query parts of the Ardour session itself. So you first need a session object, and then you can call a dedicated function from that session in an object-oriented programming languages. And most of the Ardour C++ objects and their methods are directly exposed to Lua. We didn't do a complete one-time export of all of the symbols, but we went step by step. And the idea was to both document them while adding Lua bindings and also writing small example scripts that are going to come in handy later on if you're part of the workshop. So it's an ongoing process to keep adding more functionality that exists in Ardour and expose it to as Lua bindings. And the nice part is that one can call directly all those C++ functions from any Lua script. So it's as if you're using the UI can just type in instead of clicking a button on the UI. And here's an example of left side is a C++ code. You have a session object, and in C++ you use an arrow to access as a pointer. Lua doesn't have pointers, but the Lua syntax is just to use a colon, which can be confusing because colons in C++ are used in a different context. Or the same, here's an example to get the actual speed that the transport is rolling. On the left side in C++, you call a function. On the right side, you get a session object. And then you call the function and print it. So we have all the building blocks, and we can start doing some Ardour scripting. And in Ardour, there are different kinds of scripts. The most common ones are editor action ones. Those are user initiated, and you can do batch processing from those. And you can also run them interactively. It's the most common type of scripts that are around. The second part are callbacks. They're triggered automatically indirectly by an action. Maybe a record changed or the session is saved, and it's a trigger that eventually runs your script also in UI context. Or you can do post-export automation and run a script that does extra functionality there. They're kind of rare. What I didn't expect, I thought like they might be more useful. The same is with session scripts. They run in real-time context at the start of every process cycle. What I didn't expect is that DSP scripts became so common, and they're just like normal plugins like VST or LV2 or LATSPA. And the interesting part is there that you have from the plugin that runs inside Ardour on a track, you can access the Ardour session directly and use additional information that is not available to other plugin standards. Or you can modify the session from the real-time context. There's a few session setup scripts that run once when you create a new session that allows to add additional tracks or do auto connections. And last but not least, there are a command line interface that completely replaces the UI. And you can script your whole Ardour session in a session or run it headlessly, just open it and use a control surface without having any UI at all. It comes in handy. So here are a few examples for editor actions. There's one, the common one that we ship with Ardour is list all plugins. People liked it a lot, so after you're done, you just click on a button and it prints out a list of all the plugins you're using. Or you can sort your tracks alphabetically or group them, get all the drums together instead of doing it manually. There's one that reverses MIDI events, and there's maybe 80 or 90 these days, many contributed by other users to come with Ardour. Callback scripts are one that periodically saves the session or creates a new snapshot. That's also a nice feature that isn't built into Ardour. Like I wonder every 5 minutes a new dedicated backup. One is an on-air tally light. As soon as you record arm the session, then a script is triggered that can later on turn on a light on your outside of the studio. It's also a very one-off solution that won't be built in, but you can do that. Session scripts are something like a mixer scene sequencer. It runs in real-time context, as you may remember, before doing any processing, so you can check the transport position. And as soon as you roll through a certain time point, or if there's a marker, you can take an additional action before all the processing starts. And one example is to restore a mixer scene or completely change the automation. Another one that is nice for theater production was to stop on marker. And so you can roll, and then Ardour stops at a transport at a certain position, and then you wait until maybe the next song, or you do an announcement, and you can keep going until the next marker. So you have an internal sequencer that stops at a certain position. It can also be scripted easily. Then there's for the DSP part, there's a very large Lua script contributed by Albert, actually 3 of them, which are arpeggiators. There's an inline scope, which can shows either a small waveform or FFT inside of the mixer strip. Another example is a voice level activate. You load it as a plugin, and the plugin can detect then if there's a signal exceeds a certain level, it starts the transport in Ardour. It's one feature that you can't do with a normal plugin because you don't have access to the internals of the transport control in this case. For session setup, I already mentioned live band setup, or you can just create automatically tracks and auto-connect them depending on the venue you're working on, and a headless session would be example scripts. So how does a Lua script look like? And first you need to declare as a header what kind of script it is. Either action script or a callback. And then afterwards there's one function that is the entry function that is called when the script is triggered. And for certain DSP scripts or callbacks, there needs to be additional specific functions, like audio callback, or you need to specify parameters for the plugins. And I'm going to elaborate on those in a bit. Every Lua script has access to the session, so we can query it from, and only the UI scripts can access the editor of the UI as well to perform dedicated editor actions. And all other instances of classes in C++ need to be retrieved from either the session or the editor, or created by a constructor in Lua. So if you want to get the tracks, which are also class instances, you call session get tracks, which gives you a list of all the tracks in the session, or you can give me all the plugins of a dedicated route. And all those instances are specific functions that are either from the session, or you can ask the editor, which are global variables in Lua. And everything else, you need to ask a C++ function to create the class for you. And here you already see there's colons in C++ for constructors, and in Lua there's just dots. So just a different syntax to get used to if you're coming from C++. This is one of the very simple example of an editor action script. And you specify a factory that generates the script, and then a function, which is the code that is called once you initiate it. And this would be to call a simple function in the session which goes to start and rewinds the transport. Do the same with, in this case, editor at location mark is a function that is provided by the editor. And you can see already a constructor for a time position that starts by asking the actual current position of the playhead from the session. Specify additional flag to get, it's a CD marker and not a normal marker. And then the last one is used for queues, in this case, unused. So it's another example. For DSP scripts, there's two required functions. One is an IO config that specifies how many inputs you have or how many outputs you have. And then one function that is called run, which is a process callback in real-time context. And there's a couple of optional functions that you can also specify. Whether you have MIDI input that returns true if you also want to have MIDI, which is not part of the IO, because there's only MIDI is not delivered. MIDI is delivered as a Lua table and not delivered as an array of audio of the audio stream. You can have additional parameters for a plugin, which are control sliders basically. There's an init function, which is called once with a sample rate when the plugin is instantiated. It's also optional. Sometimes you don't need it, sometimes you do. And the configuration function, which is called every time the I/O changes, in case like you change a mono track into a stereo track or back, or you add another plugin beforehand that has additional outputs, then the I/O can change. The parameters are passed as a global variable, control ports. And MIDI data is passed, as I said, as a table and a global variable MIDI data that you can modify. And the script, of course, has access to the current session. You can query additional data from the session. You can even query all the data from other plugins which exist in the session. You can modify other plugins from that context. So you can do very powerful plugins which are not otherwise possible with VST or LB2 in this case. Here's an example which is more elaborate. In this case, a small distortion. First, there's a IO config, and it specifies here if it's -1 on both cases, you can match any number of channels. And we follow the audio units back there, so you can even have -1, -2, which means you have twice as many outputs as inputs. And, or you can specify a dedicated number of inputs and outputs. And also as an array, like you can say, like I have 1 input, 1 output, or 4 inputs and 4 outputs. Like it's completely flexible in this case. And then a simple callback function, you can get ins and outs, which are just floating point arrays that you can access. By default, Ardour does also in-place processing. So normally your input buffers are equal to the output buffers, and there's no separate arrays. So in this case, I just check that I first iterate over all the channels. You can see the for loop again, starting at 1, index at 1, and then going up to the number of outputs. The hash is a Lua specific keyword to show how many entries there are in an array. And I check that the nth input equals to the nth output array, and then I can get directly a reference, which is called the array function in this case. Gives me a pointer to the audio data, and then I can just loop over the number of samples. In this case, also starting at 1 to the number of samples, and modify the buffer in place. Like the first audio sample is just modified by a half of pi, and then the arctangent function is a small overdrive that's nonlinear mapping of gain. So it's a nice simple example script to base things off. The callback, or we call them hook scripts internally, require first a signal function that returns a set of signals that will trigger the callback. So there can be more than one that triggers a given script. And then a factory function to generate the callback function. And the callback function first receives the signal that actually triggers it, since you can have multiple ones. Then you can get a reference to the object that causes the signal to be triggered, and an optional number of parameters. In this case, ... in Lua allows to specify an ongoing number of optional variables that can be appended at the end, that you can query then afterwards. One example is like if you add a new track, then you can subscribe to the Lua signal route edit. In Ardour, everything internally is called a route because it routes audio, even if it's or MIDI, even if it's a track or a bus, it's the same. And then you get a list of all the new tracks that are added, and then you can do something with that if you like, maybe auto-connect them or add a plugin to that. So you can have a script. As soon as you add a new track, it will automatically load 5 or 6 plugins and configure them. It would be another use case for a callback script. Here's the tally one that I alluded to earlier. First, we create a set of Lua signals. Then we add, in this case, record changed state signal, and then later on you see that every time this is called, we can check, is the session actively recording, and we turn on the lights, and otherwise we turn off the lights. In this case would be some external function that handles this on the hardware.
Sorry, you said it's inherently real-time state.
Mm-hmm.
So now it calls some shell commands. So is that different threads, and who makes sure that I'm not shooting myself in the foot?
I'm getting to that in this case. Well, there's two parts to it. The callback scripts, as well as the editor action, they run in the GUI context. And they don't need to be real-time safe. We need the real-time safety for the session scripts and for the DSP scripts. That's where real-time is important. And in this case, even OS execute delegates it to another thread that actually does the execution. This is not like a wait, this is a fire and forget method, in this case, OS execute. We re-implemented that. It's not the default Lua, we wait until the command returns. But this writes the command that you want to do into a buffer, and then it happens on a different thread as well. And it even uses vforks, so we don't interact with any system. Fork is also a waiting command. It copies all the memory part of your application, which isn't real-time safe as well, so you can't fork from any application that is supposed to be real-time safe. We took precautions for that as well. So, are there any other questions so far? Come again.
Is there a way to store local state, for example, per instance of each?
For each of the scripts, I think I'm going to get to that. Because GUI and action scripts, once they're loaded, they're stored in the preferences. So when you set them, they're available to all the sessions that you load them. And the DSP and session scripts, they're stored with each of the sessions that you load those scripts in. And you can store the state, you mean of a plugin, for example. In this case, Ardour stores the parameters of the plugin. When you save the session, exactly. Yeah. I don't think you can. From a not in real-time context, you can't save. Okay. Oh, in this case, no, you would restore it every time you load the session. The script would be called, the callback would be called, and turn the light back on or turn it off depending on the record state. Okay.
In the beginning of the workshop, you said that Lua is real-time safe. But
yes.
How is it real-time safe if it fits, I believe, has garbage collection?
You can specify a dedicated memory allocator. So in this case, we just use a memory pool on the back end. And there's no additional memory allocations to the back end. And there's no global lock, like Python has a global lock for doing garbage collection. Lua doesn't have that one. And the garbage collector in Lua, you can also tweak it to all your delight. Like it's very flexible in this case. And it is garbage collected. But in this case, it would just free part of an existing memory pool, which is not an issue at all. And it's single-threaded as well. So like we don't need a lock on that part. And,
yeah. So you have a modified Lua interpreter in Ardour?
No, it's a default Lua interpreter. You can just specify your memory allocation function, and you can specify the garbage collector. You can set hints for how it works. And it's just a part of the default Lua interpreter. There's nothing that needs to be done to get that feature.
Okay, cool. Thank you.
And if you know it's realloc, you just need to implement that part. And then that gives you free and new and everything by itself. Following up on this, scripts need to be self-contained. So we try to not rely on any external resources. A nice part of that is you want your sessions to be portable. Like if an Ardour session, I want to move it to a different machine, and it should work just the same. So it shouldn't be able to load any external files for the script itself to run. Lua itself can do, like the DSP part, you can load, for example, impulse response files during the setup part, like the initialization or the I/O config when it changes. So those are not real-time safe, the same as with the plugin. But otherwise, the script should be self-contained and also not use any external libraries from Lua because they may or may not exist on another machine when you load the script. When you need those, you can just copy or paste them directly into the script itself. That works as a nice backup. And that might also explain, you have been wondering why we have this factory function early on when you initiate a script that evaluates all your script at once and pre-compiles it. And then we have one function that has all the libraries that you may include or have copied into your script directly already available as a function in Lua. Because as Lua has first-class citizen functions, you can assign them to a variable and then directly use them without having any overhead. And we can do that also before allocating a memory pool. So all those external libraries don't add additional memory that you would need have at runtime later on. This is a bit of an optimization part. Ardour is highly multi-threaded, like everything can run tracks in parallel, and also all the control surfaces are multi-threaded, but Lua itself is single-threaded, and hence we needed to have some compromises. In this case, all the editor actions that you run in the GUI, they run in a single instance, and the UI is also single-threaded. On macOS, that's a requirement. On Linux with X11, it's also common to have one thread that interacts with the GUI, and then you have a lock, there's not multiple threads, and we use the same thread for the GUI interpreter. And that also shares the complete namespace and variables. So if 2 or 3 different scripts that you run in the editor, they can also interact with each other by sharing variables, which can be both of a feature and a bane depending on who you ask. Sometimes you use the same variables and you can get yourself into trouble. But Lua offers a workaround, a keyword local that you may have seen, which specifies that this variable or function is only in your context and not shared with anyone else. So use it extensively if you're writing your own scripts. As opposed to the callbacks, they're triggered by C++ action handlers, and so each of them runs in a dedicated Lua interpreter, which is generated specifically for a callback. And those are run, again, when you reload the session. In this case, it would turn on your light again, because there are separate interpreters that are just triggered again for each of the callbacks that are registered. Similar for session scripts, they run in a shared instance in the main real-time thread before processing happens. As opposed to DSP scripts again, each of those has their own interpreter that runs in the process thread that currently does the processing for your current track or route in this case. And there's one per plugin. Now we're getting into the more details. It's very common to use reference-counted shared pointers. I'm going to elaborate on that. And sometimes you have an object in C++, you have a pointer to, you initiate that, and you keep it around, and every time you use it, you increment the counter. And as long as this counter stays above 0, the object stays alive and is not freed. And as soon as it's no longer used, then it can be going to the garbage collector and the object is freed. Lua doesn't have the concept of that. First of all, it's not a typed language, and also as soon as you use a variable in Lua, we need to keep a C++ reference assigned to it so you can keep using the object in Lua. And we do that internally behind the interpreter before we're passing on any object to Lua for use. For example, well, the session is one example because the session object always exists. It can't be nil. On the other hand, it's good practice to just assign nil to a value or use a local variable if you don't use it anymore. Otherwise, Lua will keep a reference to an object and it won't be freed. And you can close the outer session, but Lua might still have a reference around it and it won't be freed, and you can run into issues like a track may still survive even though you close the outer session. There can be some edge cases that some people ran into early on. So it's good practice to use local or assign nil after you're done using a specific variable in a Lua script. Also, pointer classes, shared pointers, cannot be created in Lua. You always need to call a C++ constructor that we've seen earlier to create one of those, and then there will be a reference count on the C++ side until you assign nil on Lua, which decreases the counter again, and as soon as it reaches 0, it will be destroyed and won't be around anymore. Okay, closing in. One internal aspect of Ardour is how time is managed. And you've already seen earlier on there was a constructor for a temporal time pause. Ardour distinguishes internally between audio time and beat time. And this is a very important concept because if you move, say, for example, a MIDI region 1 bar forward and you move it exactly 1 bar backwards, it should exactly have the same position as it was before. And if you would use audio samples or even double time, any other time format, then you need to do rounding depending on the BPM, how many audio samples does it correspond to, and then you move it forward, it might end up 1 sample forth or back, and you move it back up, you get rounding issues all the time. Similar issue if you just keep extending it, like copy-paste MIDI regions onto each other, and you might have off by 1 errors depending on how long the region is. So since Ardour 8, we have completely 2 different time domains for audio and beat time or music time. And to convert between them, there's an object called a tempo map. There's another one that you can retrieve from the session as a global variable. And you can use different functions. They're all in temporal to create a time pause from samples. There's one from ticks, which is bar beat time for music time. One dedicated for beats itself, which is independent of how long your measure is. Bar beat ticks depends on your music meter or metrum, and beat time are always a beat is 1 beat. And we also distinguish between absolute position and relative position. So there's a time count, which can be negative as well. A position is always positive, starting from 0. And count you can subtract from a time pause, and you will retrieve a time position again. And in this case, would be just like getting the nominal sample rate 1 second as a distance, and then I can subtract it or add it to each of the other ones as I see fit. And it's very glitchy in the scripting languages, but since we exported C++ as is, the syntax is a bit elaborate to create those in a script. We didn't add any syntactic sugar for that yet. Okay, time to get your hands dirty. But before that, it's like, I'm not sure how we're going to do that, but I'm first going to explain, like, to get your actual script, you need to launch it. And the most common way is to use the Ardour toolbar. There's top rights, there's buttons, and you can add them in Appearance Preferences toolbar. You can have up to 12 buttons that you can assign custom scripts to. And you can also assign keyboard shortcuts to those to launch them directly for the editor action scripts. Then for all the other ones, it's going to be Ardour, Edit Menu, Lua Script Manager. And for interactively scripting, there's a window that you can type scripts in. And for on the mixer for DSP plugins, you just load them like any other plugin in the DAW. Last but not least, where are those files saved once you create your own script? And they're in, usually for user-made scripts, they're in XDG config home, Ardour, and then the major version number, which currently is on Linux .config Ardour 8 scripts. And well, macOS is hidden in libraries preferences, on Windows in local updater, so in case it matters. And those scripts need to have a .lua extension, otherwise Ardour will ignore them. Kind of sometimes you may want to put some other stuff in there, or you can just change the extension and you're fine. So far so good. Thanks to Paul Davies for creating Ardour, and Roberto for creating Lua. And I also brought a Lua book in someone case wants to find it. But there's also a library. I mean, you can go upstairs and see if you can find the book, because I have only one, and they might have it. For getting into scripting, there's a complete Ardour manual that documents all the bindings. And about half of them are documented, and all the other ones you can just maybe guess what they do, even if they don't have a description. For Lua itself, the previous edition of the book is online available. They do that always as soon as a new edition comes out. The old one is made available as PDF, and it's pretty much good enough if you want to learn Lua already. We have lots of example scripts. Some of them I'm going to show right now, because I'm not sure how we're going to do a workshop here for scripting. And there's always IRC chat on Ardour, and it's very active. If you have any questions, just go there, and then either Paul or me will be active there. And you can get help there, also for scripting. I should also mention the Ardour forum, although we don't get a lot of script support done there. Mostly people announce their scripts there. That's more common on the forum than getting help for them. Okay. Now I'm going to need an extra hand. Okay, or maybe we can just wing it. Mm-hmm.
So do you use any, for the Lua bindings, do you use any bindings generators?
Okay. Here we use Lua Bridge, heavy customized version. It was a C++ version, but it didn't support shared pointers. It was it was a nice project to get started with. And then we started and ended up customizing it more and more. But it's Vinny Falco wrote it, GitHub Vinny Falco Lua Bridge. No, Python is not going to be, we're not really interested in Python because it's not real-time safe in this case. We had Python bindings very early on, and it was auto-generated from all libArdour getting bindings done, but it never went upstream. It was just like a pet project from, what is it? He wrote it, Chuck. Oh, yeah, its indentation is completely yours. You can also write one line that does everything. Yeah, some people, it's a love-hate relationship. But yeah, you can write a whole Lua script on one line. It's completely up to you. Those are Lua at top right, are Lua buttons that I mentioned earlier that you can add. I already loaded a couple of those, and you can just, yeah.
Maybe we can equip you with something that will allow you to.
Here? Oh, yeah,
Maybe a little bit higher.
Yeah.
Hello? Okay. Oh, yeah, a little bit.
Maybe, yeah, higher.
Just.
Okay, can you?
Attends,
Tiens.
Okay. Whoop. Or maybe I just I can just move the limit up. Okay, and then it's just, okay. And here example is you can just right click on the and then pick. In this case, there's a drop down menu that shows all the action scripts are installed right now. Maybe there's even the one that I mentioned, add a CD marker that I can just load and click add. And then it's just whatever, when I click on the script, which is in this case A for the first name of the script, and I get a new CD marker in the GUI here. Windows scripting would be down here. And it also offers me all the action scripts in a list. And I can see the source code here as well. For example, maybe one is bypass plugins. Can you read that? Is it large enough? I'm not sure if I can increase the size. Maybe I just use it. Nope. And in this case, we ask for the selection of the editor. Then we loop over all the tracks in the editor. We get a route list and an iterator to the route list. In this case, R is going to be a dedicated route. Then we have a while loop that iterates all the plugins. And finally, we get the nth plugin in this case and break out of the loop if it doesn't exist. And afterwards, just set the plugin to bypass, increase it, and keep looping. This is a simple editor action script to, well, bypass all the plugins on selected tracks, for example. And you can just run it, and maybe I need to select the track first in the mixer to demo it. In this case, a vocal track. And then you see the plugin is bypassed, this one as well. And I can just change it here and set true to enable it again, and I click run, and directly interactively run scripts, and I can just keep editing there in the scripting GUI, and it's very handy to develop action scripts directly. There's also a lot of snippets, which we call like small examples that you can use to build your own scripts off. For example, there's a simple one is for each track. In this case, it's iterates over each of the tracks and then just sets it as active, or I can print the name. Just the second function here, print the name. So if I just loop over it, see all the output directly below of all the tracks in the session. And the idea is right now to come up with a few example scripts that you can implement. It was the idea of the workshop. I had like one idea would be like to invert MIDI sequence. You select the MIDI region, and then you chromatically invert it. We already have time reverse, but we don't have any, or a scale reversal. It would be a fun thing to do as a workshop. Maybe we can get together afterwards and hack something like that together if people are interested. Or maybe you guys have ideas. Or maybe we can just...
In the original repository where also these arpeggiators originated from, there are some action scripts as well, which do some scale manipulation stuff, 12-tone stuff. And yes, but I just looked at those examples. They're really helpful. So
there's examples in general in the GitHub. Share scripts. Oh, I need to log in again. That sucks.
Just a comment. Also trying to contribute from time to time a script. What I noticed recently, if you use Copilot or other AI, at least to get the basic structure of a plugin, it works very well. Then regarding the functionality, it hallucinates a bit about the functions that are available, but as a starting point, maybe AI can also help.
I looked into it, and most of the time it just regurgitated code that I wrote in a way that doesn't really work.
It never worked for me too.
Since I wrote maybe 90% of all the scripts are example ones, and it just I completely recognized what it spit out.
Yeah,
And,
it's more like if you don't do it so often and you forget difference between editor action and stuff. So
can I help with Lua in general? That's pretty good at it, but I think Ardour is probably too small a project to learn from. In this case, like there's not a, it's very niche in, it's not like you have a whole web of JavaScript examples somewhere lying around. For web stuff, it's very easy to program, or like C++, some of them can be very helpful. But in this case, you can help with the Lua syntax, but with the Ardour integration, it's very shaky at the moment. So it might have gotten better lately, but I haven't checked. Yeah, okay. Well, I can also just list it. That might also just work where it's other source code, because all of them are in share scripts. And then we have a convention that if a script begins with an underscore, they are not shipped with binary installs. Like we have lots of scripts that's just for examples, or if you're using a developer version locally, you can also read those scripts or base them off, but they're not really useful for the general user, or they're very too specific. Or from the rewind script, you can just click on rewind in the GUI. On the other hand, it's a nice example script to show or to just use and base something else off. And it's also what I do most of the time. I pick one of those scripts and start modifying it, rather than starting from scratch and just copy one file that is close to what I want to do and then keep going. And all the ones that start with an S underscore, they're snippets. They don't really do something, so just explain how to do, for example, maybe just don't even know what the drag properties does. Just look at it. And then we also include documentation directly for iterate over the tracks. So T in this case is, see if the link works. Nope. Or not. No, it keeps loading for whatever reason. Anyway. Yeah, the class description, all the functions that are available for T. In this case, the easy would be T name gets me the name of the track. And then I have T and inputs would be the number of inputs the track has. In this case, the number of audio inputs. You can also specify and MIDI if you want to have the number of MIDI inputs. And this one just displays all the properties of the track in this case. And we get a presentation info is another Ardour internal class that every track has. That is the color or the sort order in the GUI, all the stuff that is metadata that is not important for processing. That's just for how the track is presented. And then you can get the phase control from the track in this case. If the phase is inverted or not, it's a polarity switch on the GUI. You can just get it, and then you can set phase invert in this case. First channel to true. Here's another example for soloing a track. In this case, we ask the session to do the change. We get the control, in this case the track solo control, and then we say, tell the session to set it to 1, in this case, to true, to solo it, and to ignore the groups, because if a track is grouped, you could also solo them together or not, which is the third option, which is the control group disposition. Mute is similar. We get the control from the track, a track mute control, and then in this case, another option is to generate a list of controls. So if you want to specify, I want to mute those tracks simultaneously in one go, which you can't do with a GUI, well, you can with multi-touch, but in this case, you can create a list of all the tracks that you want to have muted, and then say session set controls, and the whole list of those will be simultaneously muted or unmuted. Another nice aspect you can do by scripting for live performances if you want to have a complete switch over at some point. And a comment for a track, also another function, where'd you go? And call the function set comment. And, or in this case, we can get a gain control and directly modify it. In this case, to -7 dB. See if the page loaded. Yeah, okay, there we go. This would be a reference. It's called an Ardour track, which is a route. As I said earlier, everything that routes audio in Ardour is called a route. And then there's different functions, like we can we've seen set name before. One example that we can change the name of the track. And tracks are very small because most of the functionality is done in the route. And the functions like soloing, mute are all implemented by the route itself. And also the comment is there that we've seen earlier to change, or the comment to query it. And it's a very exhaustive web page. If you look at the scroll bar, there's a lot. You can get a number of inputs, number of outputs I've seen, and you can get the channel count. And the channel count we've seen earlier, you asked of N audio, how many audio inputs or outputs there are, or N MIDI was another example that we've seen earlier. So a third-party load scripts was the edit Lua scripts, and there you already see the 12 one that are upright in the upper right corner. They're also directly available here as a menu, and that's also how you can set shortcuts for all those because they're menu actions, and all the menu actions in Ardour can be assigned to a keyboard shortcut. And in the script manager, you can load callbacks and session scripts, for example, on the load one. Good night is a fun one. You can specify a time, and then Ardour will stop playing after 3 hours. You can keep your session, and at some point it just stops and shuts down, or stop playback after a certain time. Or in this case, the stop at marker was one example that I mentioned earlier. You just click on add, and it will see all the scripts that are loaded. Maybe you can just play. Turn down the volume, I guess, a bit. Or up. And then you see the playback should stop. I don't know, maybe I zoom forward a bit. So it will stop at a marker. And then press play again, it stops at the next marker while the script is loaded. Yep, here we go. I can also zoom in that you can see better. If I start playback again. Oop. One example for session script. Callback. Save snapshot after export is one that is kind of fun. So you have, every time you export, you create a snapshot of the session, and you can always come back to what you've exported before. It is something that we even consider to build in. It started out as a script. But sometimes it can be useful, so you can directly go back to the session that you exported without doing anything else. You can just look at the script briefly. I don't know if it's interesting. So it would be maybe snapshot. Sometimes post-export. The one. And you just see the same. There's a Lua signal set. Subscribe to the signal called exported, and then the script is called. And down here, we generate a file path where it's going to be saved, and then just create a session save state. It's a normal Ardour function call to save a session, and then we specify a file name where it's going to be saved to. And then there's additional parameters. The first one is save a template, and create a session archive. So we can maybe look them up. They're documented online, hopefully. Session save. Up. Save state. And here it says what the different bools are. The first is a pending session. It's a kind of recovery. Then snapshot, template only, and for archive. So you see all what the parameters are for the given function call in this case. Right. So should we sit down and just create some fun MIDI script? I mean, it was the main idea for a workshop. Okay, go ahead, please.
I thought I saw something there.
Okay. That was a script that generates OC messages. You can generate OC from Lua as well, and then you cannot receive right now, but you can send OC.
Okay, but there's no way to trigger script. Is there any way to trigger scripts from outside of Ardour?
Yes, you can trigger scripts from outside Ardour. Everything that's a UI action can be triggered by OSC in Ardour. And if you go to control surfaces, would be in this case appendix. And oh no, first here. Sound control. And then there is maybe it's called an. I need to look at somewhere under access action basics probably. The action list below. I was just looking for the access action Lua OSC message. Okay, there. And you might even see if I scroll down. Recording control and script. All right, it has a lot here, but I think that it might be under the list of menu actions. It could be there, and then there's the script. And you can just, edit directly Lua scripts as well, as you would do from many editor, and then you can have access directly call Lua action /script1, and it triggers the first registered script. You first need to load the scripts, and then you can trigger them from OSC directly, and then it goes up to 29. You can even have more than you can have with the UI. You can load them in Ardour itself, like if you use, where is it? Over here. If you go on action scripts, you have slots for 32 in this case, and you can trigger all those 32 via OSC or directly here from the UI. At the top right, we only had, over here, we only have space for 12. We didn't add more in this case. Okay, go ahead.
So yeah, I just started this stop and marker thing, which is great. And now I'm like, how do I disable it again? And how do I find out when I'm hacking and learning what's actually all active in the background, and how do I get rid of it?
Well, in this case, there's a small button, remove, at the bottom. You can click, and it just removes the script again. Or in this case, the stop and marker. Just click on it, and you can say remove the script. And, yeah, you need to go either there and the script manager, and then there you see what is active and what is not active.
I'm trying to remember what happens when you have a Lua exception, especially in a real-time context like a DSP script.
In this case, the plugin will be disabled and not run anymore. And on debug builds, you will get a message on standard out or standard error. So
right.
You need to launch Ardour from the command line. And for GUI scripts, you can also use the log window. And if can I produce an error easily? It will be in just window log in this case, will be logged there as well as any of the other messages.
Right, and I'm also trying to remember whether there's some way to do printfs in your Lua code, especially in the, I think I've done something like that when I programmed those arpeggiator plugins. You can do a print there?
Yeah, you can print there, and for the DSP part, you can use an inline display. There's one example, let's add a MIDI track. And we have one example that is a Lua script that is called the monitor, which is also Lua, and that prints all the MIDI notes that are sent to the track. So the virtual keyboard. And you can see that you can see note on and off messages, and those are just prints from DSP callback, and they're printed in the GUI thread. So there's a ring buffer in between, shared memory that you can use. I didn't elaborate on that. There's lots of details that I didn't touch on because it, depending on which way we want to go in a workshop, so I didn't anticipate that part. But it would be like a nice, cozy 5-person roundtable, hands-on hack session. So it was kind of a whoop. Anyway.
Yeah, Robin, I had one follow-up question similar to the other fellow about enabling and disabling these session scripts. Maybe it's a feature request, but I can really imagine that you want to, like for instance with this stop to marker, there's a situation where you want to use it, and then you want to disable it again, but then you want to use it again. Having to remove and add the script every time seems quite tedious in that case, so maybe a way to toggle on or off these scripts from this interface might be useful.
Yeah, it's a good idea for this, because there's no GUI for those of them. Like for other scripts, you can have a dialog you can pop up or do some interactive setups, but not the callbacks themselves. They could use a bypass button. Just thinking if you can implement it in Lua, but you can't because you need a UI interaction to trigger it. So it's kind of a could have an action script that bypasses the other script. So maybe there's something you could hack.
You can change the icon on the button, right? So you could just change that from the script and then also change the behavior.
In this case, it's a session script that runs in real-time context, but it has a shared interpreter, like it shares variables with any other scripts. So we could have a dedicated global variable to enable or disable it. But yeah, I think it's a good idea to add a bypass button in the UI itself, even though you could probably help yourself right now already if you wanted to. Another option would be to just use specific names for markers. That's what the restore mixer scene does. And only a marker that is prefixed with in this case, MB or M for mixer scene does the stop, and all the other markers are ignored. So you can still have markers in the session and only stop on specific ones. You just change the marker name and you don't stop there anymore. Various ways to work around a specific issue instead of stopping on any marker.
Did you have to pay attention to keeping the scripting API backward compatible between versions before? No. So you...
part of what we, other DAWs are very attentive to that, especially Reaper, so that scripts keep working, because it's the only way to extend. In our case, if an internal API changes, then the script won't work well. If you use a specific function, it won't work anymore. On the other hand, that doesn't happen really often. The largest change we had was from scripting started in Ardour 5, and back then everything was still sample-based. And when we moved to a new time domain system in Ardour 8 for the, as I mentioned earlier, we have this temporal constructors for beat time and audio time. Then a couple of those scripts stopped working, and then I took some effort, at least all the official ones, to port them to the new API. But it's also not, it would be more work to keep the old APIs valid, and then changing scripts is a lot easier to updating the new APIs. Ardour doesn't change it often because also it's very robust. Sessions also need to sound the same. It's an indirect part. If we change Ardour itself, then we need to be careful that if you load an old session, we still can load Ardour 2 sessions in Ardour 8 or 9 these days. And some of them sound different because crossfades changed at some point, but we are kind of attentive that there's no significant breakage in how the session sounds in this case.
Changes in the binding generator.
Yeah. The other part, I started with the binding generator, and then I found that a lot of the bindings didn't work or didn't work as expected. And then I had a complete different idea, like I test every binding, or mostly add them manually, or well, partly auto-generated, and then I write a script to directly test it. And I can do unit tests as well, to a certain extent for that. Another fun script is you can also read complete audio. There's a script that does audio to MIDI translation using web plugins. It's kind of a fun one. Maybe you can also show it quickly. Take some, I don't know, maybe make it shorter that it doesn't take so long to analyze. And maybe I just pop it up over here. It's an action script, and it's called polyphonic audio to MIDI, I guess. So I select an audio track and then a MIDI track where it goes to, create a region. Run the script. Oh, and it analyzes the audio region by instantiating a VAMP plugin. VAMP are, some of you may know, it was presented as LAC in the past. It's an offline plugin format to do feature extraction from any audio. In this case, it does a pitch detection, and it generates MIDI from the pitch in real time, offline. And I get a MIDI region, so I can just maybe first solo the track. Playing. Oh, I need to connect the output, I guess. Kind of a Wurlitzer, and then I can play the, in this case, just a piano doing the same. Another example is a Lua script and not a built-in feature. And it's not that long. Another nice part is you can specify an icon at the end. So you can draw a small symbol. In this case, it would be the note symbol on top. So if I load the script on one of those buttons, I can get a nice symbol or a description of what it does. And if you don't have this icon function, it would just take the first letter of the script name. So in this case, it was the A for the add CD marker script. And shift right click is the general delete operator in Ardour. If you don't know that, if you shift and right click on anything, it removes it. So in this case, removes the script over here. But also shift right click on any of the audio regions, it will be gone. So it's another hint if you didn't know that yet.
How do you open the editor?
It's window scripting. Go back, it was on a slide. I'm not sure. Can I upload slides somewhere? That was another question for Roma. Because nobody asked me for the slides so far. And it was on how to load a Lua script part. You can, for new plugins, maybe I need Albert for demonstrating his arpeggiator.
That will be demonstrated on Saturday.
Well, maybe just load it on a, bring it with the plugin manager, and then you search for ARP. And you see there's a type Lua script, and there's 3 of them with different flavors. One downside is for creating those DSP scripts. You can't use the scripting editor itself. Those are only for GUI actions that you can write. So if you write source code for the DSP scripts, you use your whatever favorite editor is. Emacs, Vim, Visual Studio, or pick your poison. And there you see it's a basic UI for, does it do by default by anything? Do you need to roll to get anything of it?
Need to play chords.
Maybe I just need a live. Okay, give me a second. This is the input. And this one the metronome. It's rolling. Transport is rolling and the track is soloed, and I'm on the right. Maybe it's broken. Division, octave up, octave down. Swing, sync. Maybe I need sync. Okay, well, we'll figure it out. Typical demo effect in this case. Oh, hang on. I need to put it before the sync. That would make sense, right? Okay, The other one's examples here. The one that it's an inline scope. It's also a Lua plugin. Shows the waveform in this case. And I can log scale on as a control, so you can get more details. Is there anything else? More examples?
I often have in my workflow the task. I often have in my workflow the task to export all ranges and normalize it as MP3 files.
The nice thing, you don't need a Lua script for that. Ardour has it completely built in already. Go to export, and then you can specify time spans. In this case, you already see all the ranges, and I can select all of the ranges. Okay, I don't want to take real time off. And then you can specify file format. In this case, you want MP3. I think we need a new MP3 preset. I can edit it. And in the export format, you have normalization. You can do peak normalization or loudness normalization as well. And you can either limit it to, also constrain it. There's a built-in limiter as well. So that I can specify, am I normalizing to peak value or normalizing to the average loudness for streaming services. And another nice aspect of that is many users miss this preset button at the top. And there's one, for example, that says streaming. And in this case, you get 4 exports at the same time. Like each of your regions is exported 4 times. One's normalized in this case for Spotify and SoundCloud. Then there's one normalization for YouTube and Deezer. They have, if you look in the settings, they use -14 dB and at most 1 dB TP. And if you go, for example, Apple Music, they want a different format. They want to go -16 LUFS. And in this case, you can do 1 export call, and you get, in this case, 4 times each of the ranges time spans you have. So in this case, I would get 1, 2, 3, 4, 5, 6, 7, 8 times 4, 32 files on disk if I click export right now. And yeah, and then it takes some time. But that's you can export via Lua as well. And that's also one of the example scripts that we use a command line tool for it. Because you don't need to start Ardour to begin with. You can just do it from a command line and then export it without even starting Ardour. So maybe I can short example on that. Maybe headless is an example. That's an old one. It's a script that directly loads Ardour from the command line. You can specify the Lua Ardour, in this case was Ardour 6 as an interpreter. And then it takes, 2 arguments that you pass on. Connects to check automatically, the audio engine. Then you load the session. That's where the 2 arguments come in. And in this case, it just waits forever and does nothing. The idea there was like the session already set up for a control surface. Another one, instead of waiting forever, you can just comment it out and then go to start and say play now and wait forever. So in this case, you load the session from the command line, it would play, but you could also just export it from there instead of waiting forever. So there's, you can completely script it without even using the UI. If I have an export example, I don't think I have one ready. Oh, maybe there is the post-export hook. Export tracks, that might be something that's interesting to you. In this case, there's session export track, and it would just do a whole track export at once, but not a region. It's something we could do as an example. I'm not sure if it's going to help if I'm going to show it right now, but I think your use case is better served with a built-in feature already. All right, shall we have an early dinner? an example? Or
In the UI, is there a
No.
quick way of editing those?
no, you need to have your own editor, external one. You can only edit UI scripts in the UI itself. All the session and real-time scripts, because once they're loaded, you cannot modify them anymore. So it's kind of a chicken egg thing. And then we figured out external editors are much more common for people used to an editor already. So just the built-in one is very rudimentary. It's not really an editor, it's just a text entry box. It doesn't even have undo if you're careful. It's just the scripting one. There's no, if you change something, then it's gone, like there's no Control-C. And it doesn't do auto-intent, and all the nice features that you would expect from an editor is not in there. I had the idea to get NeoVim, which you can embed, but then I got flagged from Paul, who's an Emacs user, and then depending on which editor we pick, it's kind of, so like, okay, let's not go down that route.
I have a question about editors. Is there a language server to have code completion in different?
Not in Ardour, in this case, no.
Okay. How difficult to?
I mean, you could just use your own editor. The scripts are saved on disk, and you can just edit them directly.
But to have
the bindings.
Code completion in NeoVim or in this code, you would need to have Lua language server with.
No, we don't have that.
Okay.
But we are welcome for pull requests. Like if you want to send to us one, I'd be very happy to merge it. If you know. Okay.
Not yet.
Okay. But in this case, it would be the documentation we extract directly from Doxygen, and we just dump all the bindings by running Ardour itself, and it just prints the bindings, and then there's a small tool which is everything is built in. And so we could also dump in a format that can be read by an editor. So far, for the generation of the website, that also happens via an intermediate format, in this case JSON, and then that generates the website that we serve as a manual. And so we have all the bindings already somewhere, and then it would be probably not that hard to tell an editor just to read them, to do completion there. All right. Okay.
Thank you, Robin. Before you guys go, a couple of technical informations. I'm just going to plug my laptop quickly.